In this video, I'm going to provide a brief background to the Vibrio and Parahemolyticus oyster model. We'll be using this throughout the certificate program, and so feel free to refer to this as often as you need to. What you're looking at here is a conceptual risk model. So when we talk about doing risk profiles and risk profiles producing conceptual models, this would be a good example of the concepts. Here's how this one works. We begin with the water temperature here. This model starts with water and the oysters in their natural environment. So there would be a region of the country and a season of the year. And for each region and season, there will be water temperature data. The water temperature is a primary determinant in the number of Vibrio that are found in oyster flesh. So we begin with water temperature, and then using the scientific relationships that have been found in the literature, which we are not going to concern ourselves with, the model estimates the total number of Vibrio parahemolyticus per gram of oyster flesh at the time the oysters are harvested. Now, not all of those Vibrio are going to be pathogenic or harmful to humans, so at some point in this model, we'll have to figure out the ratio of pathogenic to total Vibrio per gram in oysters. That's actually done in the model near the end of the calculation. But in this conceptual model, the need to do so was recognized very early in the layout of the conceptual model. So in the conceptual model, they're working with the number, of pathogenic Vibrio parahemolyticus per gram of oysters at the time of harvest. The next concern is what happens after harvest. So there is a duration of the harvest, the length of time that the watermen are out there working. There is a time to refrigeration. If you have opportunity to look at some of the YouTube videos, you'll see that the watermen are very busy harvesting oysters and not so busy refrigerating them immediately. So the oysters, once harvested, remain on the deck of the workboat. While they are there, the air temperature becomes an important factor because that is a primary determinant of the growth rate of the Vibrio in the oysters as they sit on the deck of the boat. Okay? So, using that information and predictive microbiology, we are able to estimate the number of Vibrio parahemolyticus per gram of oyster flesh at the time the oysters are initially refrigerated. So they go into refrigeration at some point, and the cool down time is going to vary from one boat to the next. Some people might use ice, others might have refrigeration units. Some people will use a lot of ice, some people will use not so much ice, so the cool down time is going to vary. And while the oysters are cooling down, the Vibrio continue to grow. So once again, we are estimating the number of Vibrio per gram of oyster flesh at the time the oysters are finally cooled down. Now, while they are in refrigeration and at the colder temperatures, the bacteria begin to die off. So the length of time that the oysters are stored in refrigeration at cold temperatures is going to be important. And that will vary as well. Some oysters are actually eaten the same day. Others may not be eaten for a week or more later. So the die-off rate will vary from one eating occasion to another. We look then finally, after the time in cold storage, at the number of pathogenic Vibrio per gram of oyster at the retail level. This is right before consumption. So we have this story that we've been telling is basically all done to try to estimate how many pathogenic Vibrio do you have on average per gram of oyster flesh at the time you're going to eat them. So on the left here we see the next concern is the grams per oyster and the number of oysters per serving. So the grams per oyster is the size of the oyster times the number of oysters eaten. This gives us the total number of grams of oyster flesh consumed. From the earlier model components, we know the number of pathogenic Vibrio per gram. So this gives us the number of pathogenic Vibrio per serving at the time of consumption. That number at the bottom, now remember, this is at the time of a risk profile when people were developing the model conceptually. When the time came to build it, it was done in a slightly different order, as you'll see once we begin to work with the model. But we do get the number of pathogenic Vibrio per serving at the time of consumption. And there is a probability of illness associated with that number of pathogenic Vibrio. Using that probability of illness, then, we make an estimate of whether any one individual would actually get sick or not, given the probability that is determined by the number of pathogenic Vibrio that they consume in the oyster flesh.